Today we're going to be talking about some free open source software called WLED. It's great for creating your own LED light strips. And LED light strips are really versatile. They're good for things like Christmas animations, but they're also good for accent lighting around the home. So we've got it in the kitchen, for example, under the worktops. It works really well there, and a few other places as well. They're also really good for using as night lights because LED light strips have got really good dimming capabilities. So you can dim them really low and also set them to say a yellowy orange colour so that it filters out the blue light for night time. So the topics we're going to cover in this video is the different type of LED strips briefly first, and then the easiest way to get started, which is with a pre-built controller and a strip of LED lights, and then building your own with components like these and a microcontroller. And then we're going to look at the WLED software. They've got an app and a web page. And of course, we're going to look at the integration into Home Assistant. So let's dive in. There are various different types of LED light strips, and we're certainly not going to cover them all here, but I'm just going to talk about a few. So firstly, we've got the WS2812Bs. These are 5 volts and they are individually addressable, so each LED can be a different colour. You've then got the WS2815s, which is very similar to these, but instead they run at 12 volts, which has some advantages, which we'll talk about in a minute. And then you've got the SK6812s, which runs at 5 volts like these, but also has a white channel, which can be really useful because the white on these is not a pure white. So if you really want a pure white, then you'd go for those instead. One of the problems with these LED light strips is the voltage drop and high currents. And with the voltage drop, you can get an inconsistent light across the light strip, and also there's increased risk of fire with higher currents as well. So this is why the WS2815s can be a good option, because they run at 12 volts instead. Also, they do have some of the 2815s that have a backup data line, and this means if the data channel gets corrupted on these, then all of the lights unfortunately will stop working. Whereas with those, because it's got a backup, they will still carry on working as long as only one LED is broken. If saving money is your main thing and you're not too bothered about pure white, then I'd go for these cheaper 2812B ones, which are very popular. Otherwise, I would go for the 12 volt 2815s, particularly if you're going to do a long set of lights. Or if you've got an area where you really want to have a nice clean white, then I would go for the SK6812s. But just bear in mind that there you're going to need to use power injection along the strip so that you get even lighting across it, because they run at 5 volts. If you're feeling more adventurous, then you can build your own controller instead, and that's what we're going to do in this video here. This is what I've done. I haven't got any pre-built controllers myself, but that's partly because I started out with these LED light strips before WLED existed, and now you can buy lots of pre-made controllers quite cheap from places like AliExpress or Amazon. So it's up to you, but this is a fun project to try out. The things you're going to need to build your own controller, of course, a power supply. You're going to want to make sure it's got a bit of headroom for the amperage that's required. So this one is a 5 volt 5 amp power strip, so it can do a fair amount of LEDs. You're then going to want to have the microcontroller itself. Bear in mind that this can only really go up to 12 volts maximum on the built-in voltage regulator. So if you're doing 12 volt LED strips, I would recommend powering this separately to your LED strips yourself. Otherwise, you can use the power source of 5 volts for both the microcontroller and the strip of LED lights. We've then got a logic level shifter here, which is used to change the data line signal from 3.3 volts that comes out of the microcontroller into 5 volts that is needed by the LED light strip. I've then got a resistor here to help protect the data line, and I've also got a capacitor as well, which can help smooth out the spikes in voltage and current. But if you've got a big power supply, this capacitor might not be needed. I've got some Wago connectors here as well to help reduce the amount of soldering required. And I've also got a barrel connector here as well, the female that goes into the positive of the power supply. I've got a housing here to keep all the components in. This is actually a waterproof one, so that's quite good because you could even put it outside. And then I've got some DuPont wires here to again try and reduce the amount of soldering. This has got headers on the microcontroller already, so you can just plug these straight into here. And then here I've got some JST connectors, which has got 3 wires, the same as these here. So you can see that it's got some pre-soldered wires on the end of this LED light strip at each end. So you will need to make sure you use the right end though, because the data line has got a polarity to it, so you can't just connect it at either end. The other end is just for injecting power into the light strip. And finally, I've got some aluminium channeling here with the diffuser. I would recommend this because it does definitely make a nicer looking light. So here's one I made earlier, or rather here's one I made 5 years ago. This has actually got an Arduino sketch on it called Holiday 2.0 LEDs, which was created by Rob from the Hookup before WLED even existed. I'm going to take some bits out of here now so we can have a look at them. And we can see here's the microcontroller. And here we've got the logic level shifter, which I've put just a bit of tape over so that if they touch each other, they don't cause an issue. And then some Wago connectors just connecting them together. And that's about it really. Because I've got the logic level shifter, I haven't included a resistor. A capacitor probably still would have been a good idea, but I've got a fairly good power supply, so it doesn't matter so much. The only bit of soldering I had to do for all of this was to solder the header pins onto the logic level shifter. You might be able to get some with those pre-soldered as well, which would mean you'd do no soldering. Obviously it's a bit of a mess, but if you're happy with that and just willing to put it in an electrical box like I've done, then it should be fine. This has worked reliably for a few years. So going through the wiring, I've got 3 volts and ground connected to the logic level shifter on one side and also a GPIO pin. And then on the other side, I've got a GPIO pin which goes to the LEDs. And then I've also got a ground again. And I've got a positive here, but instead of being 3.3 volts, this is 5 volts. So this goes to the 5 volts, which is on the controller here under V in. And this is required so that it can tell what the voltage difference is between the two so that it can correctly upsample the data from 3.3 to 5 volts. And then if we look at the Wago connectors here, you can see I've got all the positives joined together here with one of them. And then I've got all the negatives joined together here. So we connect the negative from the power coming in to the microcontroller and also to both of the grounds on here. And then here this simply connects the GPIO out pin from the logic level shifter to this, which then goes to the output, which is one of these. And then the other one is used for power injection. So one of them goes to one end of the strip and the other one goes to the other end of the strip to give power at the other end. And this just ensures a more consistent lighting. Well, now we're going to say goodbye to the Arduino sketch and we're going to flash it with WLED instead. And WLED has made this really easy, thankfully. You simply go to a web page, plug this into a USB on your computer and then press install. If you've not done anything like this before, then you might need to install a driver, but there's a link for the driver on the website itself. And then once we've done that, we're going to go through the rest of the setup process. So to install WLED, we're going to need to get a USB cable and plug it into the computer and the ESP device. We're then going to need to get the ESP device into bootloader mode, which can vary per device. For the Node MCU, you need to hold the flash button whilst pressing the reset button, and then it will go into bootloader mode, and then you can release the button. Then just press install on the website, and if you've done everything correctly, then it should install and just take a couple of minutes to install. Otherwise, you might get an error message and you'll have to try again. After a couple of minutes, the WLED firmware will be installed onto the device, and then it will nicely ask you for your Wi-Fi credentials for your home network. Once you've entered these, it should add the device to your home network and then also give you the option to go to the WLED homepage of the device. So it will automatically redirect you to the IP address of the device on your network, which I think is really nice. And then you can get started with some configuration using either the app or the web page. So there's a few configuration settings we want to do first. So if you go up to config and then LED preferences, you're going to want to change a few things such as the maximum current, because this is useful, especially if you've got a low powered power supply, then it will prevent you from going over that maximum current. You're going to want to select the type of LEDs and also the color order, because some strips are RGB and some are GRB. You can also do lots of other things as well. So if you look further down, you can see that there's a setting for setting buttons. So if you connect a button to one of the GPIO pins, then that can change the presets. Or you can even have an infrared receiver so that you can have a remote control that changes the presets. And also you can synchronize lights between different sets of lights as well, which is really nice if you want to have a consistent theme across your house. And then once you've saved those settings, it's time to have a play with the effects and create some of your own presets. To add WLED to Home Assistant, it couldn't be easier. You just need to go to Integrations and then it should show up automatically. If it doesn't, go to Add, find WLED and then enter the IP address. But it should show automatically, as I say, and then you just need to press Configure and it will show as a new device and it should have lots of entities. I found that sometimes not all of the entities show up against the device. If this happens, then you just need to reload the integration and then they should all show up. You should be able to do things such as select presets, synchronization between different LED light strips. It also shows a current usage estimate and also the current maximum that you set in the settings. And then you just need to create some Home Assistant automations so that they turn on and off when you want them to and with the relevant presets that you've created. There's lots of settings that we haven't looked at, things like creating your own segments and also calling the WLED API as well, so you can do some more complex things. So I'll probably do a part 2 video in the future. I'll be interested to see what you do, so leave something in the comments below. We certainly haven't covered everything, we've only just scratched the surface really. If you're interested in some lighting that's a bit smoother and you can't see all of the individual LEDs, then you can use diffusers like this in some aluminium channel. But also I'd recommend looking at cob lighting, which gives a really smooth effect without having a diffuser, because it's got a lot more LED lights in it close together and it's got its own diffuser. And if you really want to turbocharge your LED effects, then you can also try out the audio reactive functionality in WLED. So what that does is that actually reacts to your music and changes the LED to the music. You of course need a microphone for this, or you can have a line input. This is a bit more complicated to set up, so I haven't talked about this in this video, and to be honest I haven't tried it myself, but if you have, please let me know in the comments. Well, that's it for today, so please consider subscribing if you haven't already and liking the video. So thanks, until next time.